Okay, so starting with area of a circle, right here, we need the equation for that. The equation is on the reference sheet if you don't have it memorized or if you forget. So circle is area equals pi r squared. So we're going to write that down. Area equals pi r squared. It says find the area of the circle with a diameter of 8 feet. Use the value of 3.14 for pi. So they'll either say use 3.14 or leave it in terms of pi, which we'll see in some of the other problems. Do not round your answer. Be sure to include the correct unit. Okay, so here's our equation. It says to use 3.14 for pi, so we plug that in. The radius, it gives us diameter of 8, so that means the radius would be half of that, which is 4. So we'll plug 4 in, and it'll be 4 squared. And then from here, we have to follow order of operations. So 4 squared is 16 times 3.14. And it comes out to the area equals 50.24 feet squared for area, and that's our answer. It says not to round, so we can just leave it just like that. Ooh, easy enough. You will be able to use this practice test on the test tomorrow, so make sure to take good notes so that way you have everything you need. Okay, and then zooming in on this problem uses the same skill, it just puts a couple different things together. So for this, a flower garden is shaped like a circle, its radius is 12 yards, a ring-shaped path goes around the garden, its outer edge has a radius of 14 yards. So for this one, to find just the area of the shaded part, we're going to have to find the area of the big circle, subtract the area of the small circle, and then that'll give us the path area. And then once we have the path area, it says it wants to cover the path with sand. 1 bag of sand will cover 4 yards. So once we have the path area, we have to divide that by 4 to find out how many bags of sand. So area of the big circle, pi r squared, it says to use the value 3.14 for pi, so we'll just plug that in. The radius of the big circle is 14. So square that. Be careful because some of these problems, it gives you diameter instead of radius, so you have to be careful with that. Okay, and then 14 squared, we have to do the exponent first. 14 squared is 196 times 3.14 comes out to, never mind, cheat sheet here, it comes out to 615.44 yards squared. So that's the area of the big circle. And then we have to do the same thing to find area of the small circle, so we can subtract them. So area equals pi r squared. Says to use 3.14 for pi. Radius now of the small circle is 12. And then multiply these two numbers, you get 452.16 yards squared. That's the area of the small circle. To find the area of just the path, and again, this skill is so popular on testing where you find just the shaded part. You just subtract them to find that part. So we'll do 615.44 minus 452.16. You can plug these numbers into a calculator and you get 163.28 yards squared. It's another piece to the puzzle, but not the final answer. So that is the area of the path, just the shaded part, and now we need to figure out how much sand is needed to cover that. So we're going to take 163.28 yards squared and divide by 4 yards squared per bag of sand. So we just divide. So divide is what we're doing here. And then it will come out to 40.82. So that means we need 41 bags of sand. So 41. And so even if this came out to like 40.1, we'd still have to buy 41 bags of sand to cover that. Okay, we're going to flip the page over and then do the next problem, which is similar to this one actually. Let me zoom in, Lucia. Zoom. There you go. Make it bigger. This word right here. Down. Oh, sand. Sorry. S-A-N-D. Sand. Okay. Then flipping it over to the back, we have a very similar problem. Oh, get it later. He needs his paper at the end. Okay, on the back, very similar problem. It says a circle is placed in a square with a side length of 14 millimeters. So because it's a square, like it's 14 all the way around, FYI. And it says find the area of the shaded region. So to find just the shaded part, we have to find the area of the square, subtract the area of the circle, and then that will give us the shaded part. Oh, I didn't realize it wasn't all in the frame. Zooming out a little bit. Okay, there we go. Okay, so to find the area of the square, it's just length times width. So area equals length times width, which in a square is the same measurement. So 14 times 14, which is 196 millimeters squared. So that's the area of the square. Then I need to find the area of this circle. So area of a circle is pi r squared. I'm looking in the problem to see whether it wants 3.14 or the pi button, or in terms of pi, it says use 3.14. So I'm going to replace the pi with 3.14. The radius of this, since all the way across is 14, halfway across would be 7. So the radius of the circle would be 7, and it's just 7 squared. The equation. Radius, we have to do the exponent first. We get 49 times 3.14, and that comes out to area equals 153.86. Again, not the final answer, but a piece of the puzzle. So then we take the area of the square and subtract the area of the circle to find just the shaded part. So 196 minus 153.86. And that comes out to 42.14. The unit would be millimeters squared since we're talking about area, and that is our answer. So in the box, we'd put 42.14 millimeters squared. Okay, the next one, it says the circle has a center of O. Its radius is 7 centimeters. So I'm going to write that on here, 7 centimeters. The central angle A measures 40 degrees, so I'll make a note of that as well. What is the area of the shaded region? So we're finding the area of a sector of a circle. Okay, so we're going, also it says to give it in exact terms of pi, which will be important, and be sure to include the correct unit. So for this, we're going to set up a proportion. So we'll do 40 degrees over 360. So that's the part of the circle that we need. And then equals part over whole. So area of sector over area of the circle, which would be pi r squared. Okay, so then 40 over 360, we're trying to find the area of the sector, so that's x, and then area of the circle, pi r squared, so we know the radius is 7 squared, like that. We're going to cross multiply. Also note that we have to square this first, so 7 squared would be 49, and I'll just make a note of that so I don't have to like rewrite it all. And then 360 times x, 360x equals this times this. So it'll be like 40 times pi times 49. You could do that all in a calculator, but I wanted to show it. it wants the answer in terms of pi, so in this case we're not going to even multiply by pi, we're just going to do 40 times 49 and leave pi the way it is. So in the calculator I'm doing 40 times 49 is this number, so I get 360x equals 1960 pi. And then I can continue solving for x. So I'm trying to get x by itself, so I divide both sides by 360. And I get x equals 1960 pi over 360. And then the unit, because it's area, is centimeters squared. And this is the answer that I put in the box. I can simplify this, but ALEKs will accept it unsimplified. So just to eliminate errors, you can put it right in like that. Okay, next one, it says circle below has center O, the radius is 4 yards, okay? Given that angle AOB is 120 degrees, find the length of the arc AB, so we're finding the length of this arc. So we're going to do arc length first. So over here, arc length is what we're solving for, and again, we're trying to make good notes for ourselves too. So once the length of AB, arc length, it would be, we set up a proportion as well, so 120 degrees over 360 equals arc length over circumference. And circumference is pi times diameter. I'm going to continue using the same color for arc length so it kind of all goes together. And so I get 120 degrees over 360 equals arc length, which is what I'm solving for, x, over circumference, pi times diameter. If the radius is 4, then diameter is 8. So I'll put it in like that. Then I cross multiply. 360x equals, it'll be like 120 times pi times 8. But 120 times 8 is 960. So I get 360x equals 960 pi. And I leave pi. I don't like multiply by it or anything. To get x by itself, divide both sides by 360. And I get x equals 960 pi over 360. And it's a length of a segment, so that would just be yards. So that's the arc length. And again, I could simplify it, but I don't need to, so. Okay, and then area of a shaded region. So this is area of a sector like we've been talking about. So it's the same process that we did up here. So for area of a sector, it's going to be 40, oh wait, sorry. It's 120 degrees is what they gave us over 360 degrees equals area of sector over area of circle, which is pi r squared. So these equations are over. Okay, so then 120 over 360 equals area of the sector is what I'm solving for. Area of the circle, pi r squared. The radius is 4, so that'll be squared. Four squared is 16, so I'll make a note. And then I'm cross multiplying. 120 times pi times 16. 120 times 16 is 1920, and then pi just stays like that. Divide by 360, and we get x equals 1920 pi over 360, and it'll be yards squared for area of a sector. Everybody got it? Last one. This one's actually not very long. It looks complicated, but it's pretty short problem. Okay, so what they're trying to show you is that if you took a circle like this and broke it up into quarters, you could put them kind of like side by side and it would make like a parallelogram. So therefore, you could actually use the equation for area of a parallelogram. So area of a parallelogram is area equals base times height to essentially find the area of a circle. So it says the height of the parallelogram is blank, the radius of a circle. So if you look over here, the radius right here is this distance, where in this little part, this would be radius here. So it's like the height of the parallelogram. So the height of the parallelogram is equal to the radius of the circle. Zoom in more too. So you have the radius here, and that's like the height of the parallelogram. And then it says the length of the base of the parallelogram is blank, the circumference of the circle. Circumference would be all the way around. Circumference is like all the way around. So here we have like two portions of the circle. So this would be half the circumference would be the base. And then this would be the other half of the circumference. So the length of the base of the parallelogram is half the circumference of the circle. The circumference of the circle is what? Well, circumference is pi times diameter. So if the radius, it tells us that the radius equals 10, then the diameter would equal 20. So here it would be pi times 20, so 20 pi. So the length of the base of the parallelogram is half of that. So half 20 pi equals 10 pi. So it must be 10 pi. So it's saying that the base of the parallelogram is 10 pi. Use the parts above to find the area of the parallelogram. So area of a parallelogram is base times height. So therefore the base is 10 pi and the height of the parallelogram is the radius, which is 10. So that would equal 100 pi. Therefore, the circle was rearranged to make the parallelogram, so the area of a circle is equal to the area of a quote-unquote parallelogram. Use this fact to choose the equation that gives the area of a circle in terms of r. It's just the basic area of a circle equation, pi r squared. And that's how you do that one. Okay, so leave this out. I'm going to give you credit for it. For the rest of class, I want you to do Chapter 11A practice test and work on your weekly ALEKs. Okay, so to do Chapter 11A practice test on ALEKs, work on your weekly ALEKs. You can grab a laptop. If you have questions, please let me know so I can help you. And yeah, okay.